Yeah, let's start a few minutes early. So any questions for Wednesday exam about location, time, anything? Yes. Sorry? Yes. Yes. Right. 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 I think that during the class, actually, I was saying, let's for now just remember the formula. Yes. Just like how we construct this central limit theorem, we also didn't really. We just take as a fact to say sigma squared divided by 8. So for now, let's just take the formula. Believe it's true. So yeah. So let's start with a question-driven review. So ask any questions regarding the material so far. So if there's no questions, then I will continue with this confidence interval. But the confidence interval will not be on your exam. Yes. So any questions? Questions about your lecture notes? I also strongly encourage you to go through the practical exam. If you are not aware, the practical exam is on the on our course web page. So it's from last year. So at least you are expecting some similar format. And also more or less very similar difficult level. Any particular concept you want me to go through? Even, yes. For the central limit theorem, do we need to understand why the V is considered? Yeah. Also, again, we just take that as a given. Yeah. But be aware, this valid only for when you have sufficient. If there's sometimes if we start to practice central limit theorem, but without saying you have sufficient sample, then usually that is a questionable. Yeah. So usually you need to raise concern about to make sure first you need to have sufficient number of samples to practice the central limit theorem. Yeah, because there's some material probably won't appear on your exam, but there's later there's another test which I can show you quickly. There's another test which called for example, there's another test called student T test, which is designed to handle small sample. So recall when you're using Z distribution, we assume we either know the sigma or have sufficient large A. So if we don't know sigma, usually we apply this T test. So yes, questions. So are there hypotheses of the hypothesis? What's the rest of this? No, So everything before the confidence interval. Yeah. So those I just give you a little bit hint to say. Yes, question.
So what's the central here? Sorry, central limit here still hold as long as the variance, the population variance.
Yes, yes.
And so
Yeah, if you know population varies, then you do not really worry about the sample size. The sample size is only varied. You need to worry about that because you need to use the sample to estimate the variance. So there you have problems. If you say you already know the mu, the sigma, then you do not need to worry about how many samples. Have you guys all tried the practical exam? Do you have any concerns or questions? So you haven't, please. I think that we also released the solution. Yeah. So, but the best way to do that is do not like just watch the solution. Yeah. Try to do the exam by yourself. And if you do not know how to answer, then check your slides. Somebody actually sent me an email, so I share the same suggestion to that gentleman, to maybe to every of you. So then try to think, is there any other ways? Maybe we may ask you questions. Then at the end of the day, then you try to check the solution to see whether you get the right answer. Yeah. So it's not too difficult material, but we introduce a lot of concepts. So you need to spend some time to really get familiar with those. Yeah. Please, yeah. Please ask any questions or start to check your notes, see is anything, or check the practical exam. Is any concept you want me to go through a little bit? Yes.
you have to go over the central limit theorem.
Central limit theorem. Okay. So to talk about the central limit theorem, I think that you need to start with this sampling distribution. I think that I repeat a couple of times. This sampling distribution, we are worried about what? Worry about the sample means. So basically, we are not talking about individual observations. We are talking about you are repeating certain experiments. So each time you conduct experiment, probably you collect, let's say, 100 samples. Then you get a sample mean. You did another experiment, you collect another sample mean. So if we follow this IID, so I will talk about the IID next. So if you keep repeating this, so those sample means will start to more or less fall around the actual population mean. So basically, and you will obtain some kind of a Gaussian. This Gaussian will have this population mean mu at the center. And because you are falling around, right? Falling around the true population mean. So you will have the population mean at the center. And then all the variance be there will be the population variance decayed by the number of sample, your sample size. You measure a large, you collect, let's say 1,000 maybe observations. Using that to compute your sample mean. Your sample mean probably will have a smaller variance. This is basically the central limit theorem. So does that address you? Yeah. Yes.
Okay, so it doesn't matter like what the original distribution is then? So like,
Yes,
as long as
yes,
you have the
yes. You do
identical-
not worry. Yeah, for this part, actually, I spent quite a lot of words on those part during the actual lecture. Oh, I think that I forgot record this part. Yeah. So that day, I think that I forgot to press the record. Yeah. So yes. The cool part about central limit theorem is you do not really care about what is the underlying the population distribution. So it can be anything. So since we're only talking about the sample mean, so you can be arbitrary underlying distribution, but once you collect a lot of observations for this particular sample, if you compute the average, that average will more or less close to the population average. If you get more data, then you are less likely to be further away from the true population average. So in this way, you will get a kind of a Gaussian curve, right? Because most people will fall into the center. Then when you are become outlier, it's less likely. So when you become far away, further away, you will become less likely. Yeah. So does that make sense? Yeah, this is great. Any? Yes.
I have a question about the two sample test.
Yes.
Because after we calculate mu equals like the average equals 1 minus the other is 0, and then we
Yes.
talked about. So
Right.
like for that one, we compute the z-test just for compared to
a zero mean.
to like populations, right?
Yes.
Can you show us how do we determine if we should accept the null hypothesis?
I think that this is essentially the same thing as the regular z-test, because once you construct a Gaussian, the particular part here is how do you decide the center? Because in the typical the regular version, your center will be your population mean, right? But here the center will be 0, because you compare two things. You assume if they are similar, if the mean they are same, if you take the difference between the mu x1 bar or x2 bar, if you take the difference, they should be 0. So basically you have a Gaussian to match to is a 0 mean Gaussian, right? And then the variance is calculated using the strange formula. I think the one gentleman just mentioned, but still you need to normalize it to a standard normal distribution. So to make this 0 mean and 1 standard deviation, then you will just try to basically try to check if that difference is around 0 mean this 1 standard Gaussian or not, right? You just plug, because you have x1 bar and x2 bar. If you take their difference, that difference is not necessary to be 0. You expect to be 0. It should be something around 0. If it's too far away from 0, fall into the rejection region, you will reject it.
Like what are the x1 and x0 bars?
This is because in the regular hypothesis test, you just take one sample, right? You think about the factory example, you receive 100 widget, you compute the mean. But here, the difference here is that you have to have 2 samples. You get 1 sample, which is probably 100 widget, then another 100 widget. You will compute 1 mean from each sample. Then you compare that 2 means to perform the test. Then you have your standard error. You have your you compute your z-score. Then you plug in the z. Everything is the same, right?
What's the difference between like the x bar in this?
The mu, in this case, the mu, because assuming there's 2 populations here. Mu1 is the population mean for the first population. mu2 is the population mean for the second population.
I'm talking about the difference of mu and x in this case.
Yes. Sorry.
What are
X is what you compute from your sample. You take one sample, take let's say 100 widget from one population. Then you take another 100 sample from another population. Because here we are talking about you are measure two population whether they have the same mean or not. I hope you get this. Yeah. Don't worry. I think that those things after you understand it looks trivial, but before you because you don't have a sufficient material to see all the big picture. So a lot of time, please do ask questions so you can start to link everything. Yes, questions. Yes. Yes.
So isn't the standard error like a simple distribution? The population standard deviation for the root of that?
Right.
What not the standard? Isn't that the standard error of variance?
Let me bring to the part. So again, you said this.
Yeah.
You have question about this part. Yes.
So isn't the standard deviation sigma over the square?
Right.
So why the normal distribution here sigma squared not the variance?
So you see the variance sigma square here is a variance for the population. So if I let's say if we are talking about individual observations from a population, let's say like the coffee shop example, if we assume this underlying is a Gaussian, I mean it's not a Gaussian. Yeah, if we assume it's underlying Gaussian, then you take of each individual observations, then you take the that individual observation that will follow the sigma square variance. But here we are talking about a sampling distribution. Sampling distribution is not the underlying population distribution. We are talking about you take 100 sample, you take an average, you take another 100 sample from this population, take an average. Then what the average, what behavior should the average, the sample average present? The sample average will shows it will surrounding the true population mean, but with sigma square divided by a, this variance.
So sigma squared divided by n is the variance of our sampling distribution?
Yes. This is a sampling distribution. Yeah.
So is sigma squared over n the variance of the sampling distribution?
This is a sampling distribution. Exactly. Yeah.
Is it the variance of the sampling?
Yeah. It's a sampling distribution for the population mean. Yeah. So we are talking about how the population mean should spread around the true population. Sorry, we're talking about how the sample mean should spread over the true population. Yeah, you just think about that. If you have difficulty to understand this, you just think about, if I repeat the example, if I want to understand the height of the Indiana population, okay, right? So which let's assume is a 1.77 meter is an average, it's a true average, although I don't know, right? This is a hidden because we have no way to measure individual. So then I will just try to measure every single of you in the class. Then I get, let's say 1.79. If I take same measure over, let's say 1,000 class, then I get another mean, right? Then if I keep repeating these two different experiments, one is I will measure 100 individual to get a mean, get a sample mean. Then and the other one is I take repeated experiment for 1,000 people to take the mean. So obviously the second one, the average, each individual experiment should give me a mean more close to the true, right? So that will give me a smaller variance. So that is which is reason you have to decay over the A. So more sample, larger sample size, you will get smaller variation of your actual mean you measured. Does that make more sense?
Yeah, I'm just more confused why you're, this isn't a normal distribution.
Yes.
Track with the mean and deviation
Right.
of the mean curve
Right.
instead of just the variance.
Yes, yes, because actually this is still a variance, right?
Yeah.
This is only show the link of this variance to the actual population variance.
Yeah.
Yeah.
Okay.
Yes, questions?
I think it's the answer. The notation is mean. So like when you put n and then parentheses, you put mean and then variance.
Yes, right, right.
Yeah, I was thinking it was standard deviation.
Oh, I see. Because usually when you write this notation, usually we put a mu, this is a mean, and then we put a variance. We then from the variance, then you can compute your standard deviation. But usually we put the variance. This is a typical notation. But once you give the variance, you take the square root. Yeah. Yeah. Yes. Any? For people who have tried the practical exam, are you comfortable with the exam? That do you feel it too challenging or too easy, or because this practical exam, of course, we will not repeat the question at all. We will try to avoid, but more or less, you if you never say anything, this is a type of question. The similar level you will give you. Yeah, you will get a similar difficult level. Yes.
I was just looking over it. In question 10, which is talking about a random distribution, it says, it asks, is the number of customers power x that continues with discrete random variable? What about x bar sub n?
Yes.
I'm assuming that x would be discrete and x bar sub n would be
Exactly.
Okay.
Yes. Yes. Because
So how about
in fact, when this is a this assumption for x bar is holding, for people who probably who are not aware of this question I don't remember exactly the content. Has been a while. So roughly is to say, if you want to perform this kind of let's say hypothesis test or sampling distribution, when you compute this x bar, so compute this x bar. Okay. What is this, a continuous random variable or a discrete? This is a continuous because it's come from a Gaussian distribution. A Gaussian is continuous. Okay. And the underlying is independent from the underlying distribution. The underlying is when we are talking about the population distribution. It's like where the underlying individual observation follows. Okay, so that can be discrete. For example, it can be a discrete. Remember one example we show in the class, we are talking about probably some kind of binomial, right? We are talking about, I forgot the exact question. We are talking about some binomial, maybe the person who watched the YouTube video, remember that example. So this guy follow a binomial distribution to watch some YouTube video. The binomial is a discrete, right? But then when we ask what is the average over 100 days or something, then that is a continuous. So yes. Now it's time for you to go through some lecture notes, to go through the practical exam to see is any questions you want to particularly discussed in the class. Yes. In general, my understanding is if you are missing some very critical one, you will take a, we will try to punish you a little bit more. But for some very minor things, when you write, probably we will try to be forgive a little bit. Yeah. So it's hard to say. It's really depends on. I mean, we were not. First of all, we were not running your code because you are things you write on the paper, right? We will try to base on the impression to see whether this is the right syntax or not. If you're missing certain things somewhere, which in the actual programming assignment, maybe it was not running, but during the grading, maybe the grader may not see that. Yeah. So, but if it's so obvious, for example, when you write a, let's say, list comprehension, the whole syntax is wrong, then obviously you will not get points. Yeah. So, that is kind of relative, but we will try to enforce more consistent standard to say how to practice that. Yes.
Coding section and then the data science like analysis question. You say it's like 50-50.
We were more or less it's a very similar to the practice exam you were. If you are expecting to see the percentage, it's very similar to the past year. Yeah. So in general, I would say we try to spread the questions across different lectures because each lecture actually more or less we have some kind of standalone the topic, right? So we will like to try to test you on each individual. Maybe some of them probably we don't put questions, but more or less it's something like that. Yeah. If you check the past year exam, you will see how those topics are distributed. It's very similar to that curve. Yeah, I would strongly especially for the programming part, I would strongly recommend you to go through other Jupyter notebook examples. Because for the data science part, I think reading the lecture notes more or less, because we also have some working example in the lecture notes. So those should be quite sufficient. But for the programming part, we actually spend a lot of time to go through together some Jupyter notebook, right? I don't know, when I go through the examples, did you get all the points or not? So one way is to go through each of the example by yourself to see whether you are follow. For example, I think there's a couple of difficult parts. For example, for those high order functions, I think the concept is not obvious if this is the first time for you, and especially those like list comprehension. Try to go through the past year exam, because last year I think that we put quite some of this list comprehension example there. See whether you are followed because all the material we have covered during the lecture, but sometimes in the lecture notes, sometimes some of the tiny points was on the Jupyter notebook. Okay. So you have to be, because I know we all like to sleep during the lecture, so sometimes you may miss certain things. Yeah. So try to go through. Yes.
So do we have access to?
Yeah. You can access materials on the website, but I'm not saying you can use computer to access. Probably if you want to take it with you, maybe you need to either copy it down or print it out. But you can access all the notes and the whatever we provide on the website. Yes. Yes. The exam. So the physical time is 60 minutes. Yeah. Probably we need to take into account maybe the first few minutes, last few minutes, which probably you need to worry about something else. Plan yourself, let's say, for 55 minutes to answer the question. And we are going to have so initially we have 10 questions, but we want to make sure you guys are able to answer. We remove one, so we will have 9 questions. Yeah, but the number, I think that the actual there's one question. The first question is to ask you to do some pledge or something. Yeah. So, but physically we have 9 questions, and so plan well yourself. 5-6 minutes for each question. If you stuck on some question, I would say move on. Yeah, do not. Sometimes it's very pity when you're grading papers, like you finish everything at the first few questions, they leave a lot of blank at the end. Yeah, so plan well. Yeah, so each questions 5-6 minutes. Yeah, if that you are significant spend more than that, maybe you should move on. And we try to give points more scientifically, but still those points doesn't really indicate how much time you should spend. Yeah, it's a kind of you're from different backgrounds. Some people may feel comfortable with programming one. Some people may feel comfortable with the data science part. Yeah, so plan well. Yes. Yes.
For the fall 2020, for example, where it says you're not communicate with anyone for 24 hours within the exam period.
Right.
I'm assuming that's because it's
Because at the time we are doing online, we have last semester we have 3 sections because we are holding also the online teaching. So a lot of people come from different time zone. Yeah, so we have morning, noon, and night 3 sections. And also for that one, because people need to download, print, and they need to upload again. So they have we are reserved probably 20 minutes something for that purpose. Yeah. But this time we were, I think that you all checked the location. We will have an in-person exam and we will collect your paper. So there's no downloading, uploading. We will print all the exam for you. Okay, so. Yes. Yeah, please feel free to ask any questions. Yeah. And honestly, this is a one class different with so many different background. Maybe some questions is how say I didn't give sufficient treatment to every single topic. Yeah, I try my best, but again, certain topics I make certain assumption to assume you already know certain things, but probably you don't know. Then now it's a time to re-ask. Yes.
Is there any way you could post your Jupyter sample pages onto the website?
Sorry?
Can you post your Jupyter notebook?
We have, right? Yeah. So looks like you haven't accessed the yeah. So go to check. I think we at least we have the essential part posted on the website. Because maybe different professor has slightly different version of material to present during the lecture, but what we present on the website is a more fair version material to other sections. You should have access to that. Okay. Yeah, I can give you another 5 minutes to still think about anything you want to ask. Yes.
Do you have any practice questions you can go over?
Sorry.
Do you have like any practice questions you can go over? Practice ones?
I think the one. First of all, I would strongly suggest you to go through the practical exam. like using the way I try to suggest. Do not just like reading the solution, because reading the solution doesn't help you. We will not repeat the same question. So try to see whether you can answer. If you feel confident to answer the past year exam, I will say you already reach. You should not feel too worried. I mean, not by checking the solution to know how to answer. You will say without see the solution, you know how to answer. That is a very good indication to say you are familiar with the material. Yeah, and I think that we have some practical exam. Practical questions on the Piazza for the CDF for those these PDF. This one. Yeah. We might, I don't know, one professor promised to post some about central limit theorem. I don't know whether the question has been there or not. Have you seen any extra question on Piazza about central limit theorem? No?
PDF.
Sorry, the PDF one. Okay. Okay. Yeah. And also, as I mentioned, try to check those Jupyter notebook about. Make sure you, especially for the, I think for those basic one is probably easy. Yeah. For those list, tuple, dictionary, at least you know what are they. But more difficult one is try to check those individual examples about, let's say, those high order function, those say list comprehension, map reduce, how those things work. Those things is not, at least it's not trivial if you are new to the programming. Yeah. And I think that there's a couple of programming questions on the practical exam, right? If I remember, last year we give relatively tough the like high order function those. Try to see whether you can answer those. If you feel okay, I'm confident to answer those, then I say you're more or less you get other. You should not worry much. Yeah. There's not too many things. Yeah, it's limited, but you need to make sure you really understand how to use those to solve problems. Yes.
Just as a clarification, so we don't have class on Wednesday, but we do on Friday?
Yes. Maybe last 2-3 minutes, think about any, yes. I suppose it's 6:30 to 7:30 at some location, which I don't know where it is. Yeah, but check the Piazza. Yeah, it's some center. I guess you guys have, if you have taken exam, probably you know where it is. I never be there. Yeah. I think I will not be at your exam. One professor from another sections will try to coordinate. Yeah. So probably I will be there for your next exam. So, okay. Yeah, I still have an office hour for tomorrow. Tomorrow, I think that on the Piazza, you see there's a Zoom link, 1 to 2. So that will be another chance if you have particular question. But don't ask me the homework questions. I'm not too familiar with home. But in general, those your practice exam, your lecture notes, your Jupyter notebook. Yeah, those examples. If you still you discover some new doubts, please welcome to attend my office hour. So that will be another chance for you to ask questions. Okay. So maybe I will. So should I proceed to finish this confidence interval? Okay. Yeah, last class, I think that I tried to give you a very brief impression about the confidence interval. Because the reason I want to bring this confidence interval immediately after hypothesis test is really they are using very similar underlying, how say, the theorem, the central limit theorem, but they look at the problem from different perspective. Okay, so as I mentioned at the beginning, is if you see this, what does that mean? Okay, so now at least you should have a very vague impression now to say, if I tell you a value, they say the by height, okay, then I put another range here. This should give you what message? This should give you, okay, if I have assumed this is my, let's say, sample mean, and then this is a range around my sample mean, that what should tell you, for example, if I talk about 95% of confidence interval, okay, so for now, without losing the, I would always say 95 confidence interval, because this will make my content more specific. But of course, you can change to 98%, 90% as needed. So if I say this is 95% of confidence interval, that means for 95% of chance, the true population mean should within that region. All right. So this gives you a little bit of extra information, right? You see a value, you see a sample mean, then I give you a bar, then I say that is a range, that is the interval. The true population mean more or less will be here, be within this range. So that is what the confidence interval try to say. All right. So there's a many different interpretation. As I mentioned, there's like 3 different ways to say the same thing. You try to read and pick the one which you feel most comfortable. So at least I take the first one. I say 95% of the confidence interval should contain the population. Okay. So there's another way to say this is if we repeat the experiment a large number, then 95% of the confidence interval should contain the true population. So what does that mean? So each of these vertical bar is like you conduct one experiment, then you compute some confidence interval. So then you repeat this, and we expect 95 of them will include the true population, right? So this is essentially a different way to say the same thing. I hope you have a very, at least very vague impression about what this range, right? I measure certain things. I should give you a confidence interval, let's say, to say what is the chance the true population mean should fall into this range. All right. So to say things a little bit more formally, if the population parameter is outside, let's say the 95, because the C%, as I mentioned, I will keep using 95 as a particular example to say here. If the outside the 95% of confidence interval, then an event occur that have probability of, let's say, this will happen. This is essentially the saying the likelihood things. But the more interesting is like this. Of course, here we have to set the let's say 95% ahead of time. This is a little bit different from when we are trying to measure this this p-value. A little bit different from that. Here is like you want to set what confidence interval you want. You want to 95% of confidence interval. You want to 90, 98. You specify at the beginning, because you are looking for the boundary, right? You are looking for that range. If you don't tell me you want 90% or 95%, then there's no boundary to look for, right? You have to tell me your expectation. Then I will look for the range for you. If you tell me you want 95% of confidence interval, then if you end up with a very wide confidence interval, what does that mean? that means you have a lot of uncertainty in your sampling, right? Because you have to make this very wide to cover your 95% of, because as I mentioned, what does that 95 confidence interval says? That say out of 90% of the chance you will have the true population fall into. If you have very uncertain things, so you have to make your confidence interval wider. If you have a very small variance for your the variance of your data is small, and then you do not need to have a wide, you just have some kind of narrow confidence interval. So this is essentially to talking about you have a fat Gaussian or a thin Gaussian, right? If I say 95, for this guy, 95 will be this much. For this guy, 95 is probably only this much, right? Of course, the interval is very different, right? All right. 95 is how many standard deviation? It's about 2 standard deviation away, right? So this is a directly associated with how big is your standard deviation, right? So the best way to get the actual calculation for the confidence interval is to start to recall about your how we compute the z-score and p-value for our hypothesis test. So let's remember what is the definition of this score. This score is this guy, right? As I kind of wordily explain why we want to do this, is because we want to reduce an arbitrary sample Gaussian distribution into a 0 mean 1 standard deviation, the standard normal distribution. Okay, so then your X bar, your sample mean, will be reduced to a Z score, which share the same CDF, right? So basically, you have a arbitrary Gaussian distribution. After you do this, your X bar will, you will deform this Gaussian into a 0 mean and 1 standard deviation Gaussian, and this X bar will become your Z score, but the difference is this region will be the same. The CDF will be the same. All right, so I can compute the CDF for this guy and solve this problem. All right, so then when you have a z-score here, how to compute the p-value? The p-value is this and this for the two-sided test, right? So basically you will look for the negative version because they are symmetric. So you have a negative version for this guy because this is 0. So this is a negative z-score. This is a positive z-score, right? Because this is 0 and this side they're symmetric. So you just compute a CDF. CDF of this guy will be this region. And this region and this region, they are same. So you use 2 multiply. So you will get your p-value. So now the difference is what? Come to the confidence interval. I think that as I mentioned last time, if this rate is your X bar, okay, and you want to determine the range for this guy and this guy. So if unfortunately, I think that I only have 1 minute left. So probably I will stop here and good luck to your exam.